So since elementary, you've probably been somewhat aware of descriptive statistics, and probably in high school you've used some ways of presenting data. Alright, so normally we present data using tables to see the actual numbers and arranged in a systematic way using rows and columns. And you can easily see correlations in this case and the actual numbers, no, to help us more or less understand these things. However, we can also use graphical representations for those of us na mas visually inclined. No? Although this may not be as exact kasi pag nakita mo yung numbers na sinabing 18% versus 36%, you automatically know that the latter is twice as much as the former. Pero kung pinakita yun in a pie chart, hindi mo sure na exactly twice as much yung yung one slice versus the other. Pero mas magaan siya sa mata kasi walang masyadong maraming numbers na naka-display. Okay? And giving a bigger picture, as far as giving a bigger picture goes, mas madaling makita yung quote-unquote big picture because of this. Okay, so we could use different types of graphic displays. The one on the left is a horizontal bar chart. The one in the middle, this is actually from the data of one of my former thesis students, no? In-evaluate niya yung profiles ng iba-ibang puto manufacturers and nakita dyan yung mga relevant na factors. So merong, yung tawag dyan is radar plot or spider web plot. So makita niyo yung pinaka-profile just by looking at the shape, and you can also more or less quantify, no, kung ano yung meron differences doon sa bawat puto just by looking at this figure. And the one on the rightmost, of course, is the um, classic pie chart, no? And this pie chart gives us the distribution, in this case, of parang ethnicities. Most likely, ganyan ang ginagamit natin to present yung ating demographic data ng panelists natin. So usually we sometimes use the demographic data to explain the responses of the population. No? So when you have nominal data, you can also count them using the frequency function, for example, in Excel. Halimbawa, di ba ang pinahaba sagot sa demographic information is sex assigned at birth, then you have male or female. Pwede nilang bilangin automatically how many answered male, how many answered female. Or for example, marital status, single, in a relationship, married, widowed, whatever, divorced, ganyan. So pwede mo rin bilangin yung mga yon kahit na words sila, and then use a frequency table to look at how frequent each of these appears, no? Para malaman mo ilan sa mga panelists ko ang in a relationship, so on. So here are examples of frequency tables. So it just gives us how many are in each category, for example. So nominal data can also be summarized using bar graphs and pie charts. Now, yung nominal data natin, hindi lang naman yan for the demographics nga. Pwede rin yan dun sa responses ng panelists mo. Like, let's say, may kasama dun sa demographic, may kasama siyang survey on alin sa mga gatas na ito ang madalas mong iniinom. Check more than one. You can check more than one. Okay? So, ganyan. Tapos yan yung lalabas na pagka pie chart niya or pagka bar graph niya. Or for example, yung responses nila sa samples. Pwede rin naman kung something like gusto mong i-check i-graph yung comments based on certain, like, is it a positive comment on the food product or a negative comment, and then you count. Pero yun, medyo manual mo nang i-count kasi hindi kaya ng Excel i-detect kung positive or negative yung comment. So again, recall that generally there are 4 types of data that we deal with, kung nominal, ordinal, interval, and ratio. So to remember it as an acronym, the French word for black, noir, N-O-I-R. Okay, you can use that to recall. So when we have ordinal data, these are usually ranking data. And for example, in this case, pinajudge ang 25 consumers kung from the most preferred to the least preferred nila na flavor ng drinks para malaman siguro kung ano yung drink na ipopursue nitong manufacturer na gawin. No? So, here we can see in this table how many persons ranked each fruit flavor as either first, second, third, fourth, or fifth. And we could easily see in this case that strawberry more or less yung pinaka-rank 1 talaga. And raspberry yung pinaka-ayaw ng mga tao. No? So, this is just one example of combining both charts and tables para mas madaling intindihin yung overview. Take note that when we have a ranking, yung something na most preferred mo, pwedeng, ito yung pinaka-preferred ko out of the 5 but I still don't really like it. Or sabi mo least preferred mo nga itong isang sample na to pero actually masarap pa rin siya. It's just that mas gusto ko yung 4, parang ganun. So in ratio and interval data, you could actually use a number of different things to summarize them. In this case, pag histogram, usually gumagamit ka ng bins or each range of numbers is made into a category and then you treat it as a frequency count. So parang if it falls within this percentage, you count it as +1, parang ganon. Okay. Sometimes naman medyo continuous yung labas ng data mo, like for example, temperature reduction in this case. Obviously continuous yan, meron kang periodic readings na ginagawa. And the values can be anywhere from that range, may decimal points or whatnot. Another example, tulad ng pinakita ko sa puto kanina. So this is a radar chart of sensory profiling data. Say you have to compare 2 products and you can see here kung ano yung saan sila nagkakaiba. Look, the aftertaste, for example, is may small difference in intensity, but there's a large difference in intensity between the two, as oiliness intensity between the 2 samples. So parang ganun, at least ang dali niya makita ng differences. So at times you can also use box plots, no? In this case, meron ka makikita dyan, maximum and minimum values. So ito yun. Then upper and lower quartiles. And then the extreme values or outliers. So when you have bivariate normal data, you can use cross tabulations or simply display them using a table and then translate it into a compound column or bar chart. So in this case, makita natin, binibilang mo ilan yung nag-respond for a certain item. Like, so if it's a 5-item survey, then you want it to break down in terms of how many answered each of the possible responses for each question. So makikita natin yan dyan. So the table in the previous slide can also be represented using a scatter graph, in which case ang magiging labas nun is superimposed na mga graphs from each statement. Or if you want to flip the axis and show instead for each response, how many for each statement yung ganong response. So pwede rin naman. Scatter graphs can also be used for interval and ratio data. And you can use this to look for trends. Although for bivariate ordinal, madalas hindi mo makikita yun through scatter. Alright, lahat naman tayo alam siguro yung mean, and as a measure of central tendency, Ito yung isa sa mga pinaka-abusado kasi pine-present madalas yung information as mean plus minus standard deviation to give us a rough idea of the population's response as a whole. However, as we know, there are cases wherein the mean could be misleading kasi for example, if you look at the mean age sa iyong demographics, halimbawa, ang mean age na nakuha mo ay 30. Pero when you look at the individual respondents, kaya pala naging 30 yon kasi maraming mga 60 plus years old, tsaka maraming mga below 10 years old, no? Pero in reality, wala naman palang person of age 30 na nag-participate doon sa study na yon. So there's also the trimmed mean, although hindi natin ito masyadong ginagamit, wherein to remove the outliers, if you have the data array, you get the specified percentage of the top and bottom responses that you will remove. Well, there are actually a lot of ways to look for outliers, pero normally hindi naman natin ito ginagamit sa sensory evaluation, no? So again, we are all probably familiar with what a median is. In sensory evaluation, we could use this to represent either parts of the demographic, like let's say the median age, for example, or the median response if you're looking at an array of ordinal responses, or median rank halimbawa ng isang product dun sa evaluation ninyo. The mode simply again refers to the most occurring response, or the response that occurred the most number of times. No, so okay din to minsan para makita natin halimbawa sa if you're looking at different products and you're looking at ano ba yung pinakamadalas sinagot nilang level of preference for this product. So medyo may sense din naman na sabihin yon, no? But of course, sometimes you have to look at the mean, median, and mode to see if they are in agreement or close approximation with each other. Kasi kung malayo yung pinagkakaiba ng mean, median, and mode, you can use that to interpret your data set. Maybe may extremes, may outliers or whatever. We also have what we call measures of locations, no, usually yung quartiles, quintiles, deciles. Okay, so this simply means na we stratify the observations arranged based on rank into 1/4 or 1/10 in this case, no? So when you say the first decile, second decile, third decile, first quartile, second quartile, this simply means kung anong percentage ng population mo arranged by rank order. So if you say it belongs to the second quartile, then that's the ranked observations na nasa top 26 to 50%, for example. Okay, so usually ginagamit ito, pwede natin gamitin ito halimbawa sa demographics. If naka-arrange dyan yung income from highest to lowest, the first quartile would be the top 25 respondents with the highest income, and so on. So you can actually stratify your data in this way for processing para malaman kung i-divide ba natin into income quartiles yung ating information, yung mean ba ng bawat quartile ay mag-iiba ng response or something like that. No? Parang sabihin mo ba, kapag mas mayaman ba, mas gusto nila itong flavor na ito or something. So yun. So if we have a large enough data set, we can use histograms to see the extent of dispersion of our information. Na parang gaano kalapit or kalayo ba sa mean or anong shape nung bundok na mapo-form mo. So those can tell us a lot of things about how close it is to a normal distribution. Or how to help us explain yung mga conclusions na pwede natin gawin dito sa dataset. So when you're comparing apples to apples na datasets, you can use absolute dispersions, so you can use the ranges. However, when you're using relative dispersion, you're comparing two datasets na pwedeng magkaiba yung mean or units of measurement, in which case parang ang tinitingnan mo lang is yung shape niya. So yung coefficient of variation would be a good measurement for this. Okay, generally we don't want a very wide dispersion. Okay, and dito rin natin makikita yung, for example, gaano ba kalayo yung mean sa median sa mode. Ideally, magkalapit silang lahat, no? So maraming uses ang range even outside sensory evaluation. It's usually just the difference between the minimum and the maximum value. For example, when I used in the ice cream industry, yung bawat product namin, meron yung weight range and dapat pasok doon yung timbang ng kada masample mo na ice cream container. Tapos, pwede mo actually i-graph yung data to see kung the range ba na nakukuha mo sa actual is how close within the specified range limit mo. Yon, or parang mas leaning ba siya sa mas mabigat, mas leaning ba siya sa mas magaan versus the target weight. No? Kasi usually, di ba, sa package meron yan. Net weight 100 grams. So you can allow yourself 95 to 105 grams. Pero pag yung ginraph mo ba yung mga tinimbang mo, ang mean ba niya nasa 100 talaga o nasa 96 lang or nasa 104 na, parang ganon. Okay, one thing with range is it's severely affected by outliers kasi the outliers do determine the range, no? And this does not take into account um, the number of observations in between. Parang what if lahat naman 99% ng products mo ay nasa 100 grams ang timbang pero meron kang isa na pumalo ng 95, may isa na pumalo ng 105. So ang range mo ay 10 pa rin when in fact 99% of your products are within the 100 grams na exact weight. So you probably calculated for variance, no, sa inyong statistics class sa high school, and we know that the smaller the variance is, it just means na mas malapit sa mean yung set of values, no? Or at least most of the values are closer to the mean. Okay, so we use standard deviation or the square root of the variance as an easier means of interpretation kasi pwede mo siyang gamitin directly, no? Like mean plus minus standard deviation usually statistically would account for around almost 2/3 of your values. Now, for example, if you had 100 responses and you computed halimbawa ang mean plus standard deviation niya ay 10 plus minus 1, then that would mean you're expecting around 60% of the responses or 60+% of the responses to fall within the range of 9 to 11. So we could also use the z-score as a measure of dispersion. And there's a different equation as you can see here, whether you're using the z-score for a population or the sample. Simply put, no, it's the how many standard deviations away an individual observation is from the mean value of the data collection. Okay, and the negative value or positive value only indicates yung direction niya, whether it's smaller or larger than the mean. So the coefficient of variation or CV is another measure of dispersion, and it's just the relative standard deviation or the standard deviation expressed as a percentage of the mean. So you can actually use this to compare different values kasi syempre kung mas malaki yung mean, mas malaki din yung expected mo na standard deviation. But if you can convert it to percent, the percentages should be comparable. No? Mean plus minus 5% is comparable to each other, regardless of whether the mean is 10 or 100 or has a different unit, no? So typically, lalo na halimbawa sa mga laboratory repeated measurements, we usually want a low coefficient of variation, mga less than 5%, or depende kung very accurate yung instruments mo, you'd want this to be much less than 1%. However, usually in sensory evaluation, when you're using human respondents to quantify measurements, mas malaki po talaga yung CV no? Like mga 30% ganon. Kasi nga, tao sila eh, di ba? Parang pag pinatikin mo ng same drink 5 times and you want to quantify the sweetness perceived by that person, they will not always give the exact same answer for each measurement or each time you do it. Okay, next we have skewness and kurtosis. If you look at the distribution histogram of your data points, yung parang pinaka-bell curve niya, skewness would refer to how mirror imaged from the center is yung left and right points, no? Kasi kung normal distribution yan, dapat symmetric siya. Pag hindi symmetric, we have what we call the skewed to the right or skewed to the left. And we have kurtosis, which is yung pinaka peak niya kung siya ay patusok or very parang flatten the curve yung dating, no? So that would also give us an idea on the concentration of the data points. And usually, dapat pinakamarami siya near the center or the mean. And nagdidip yung tail sa bawat dulo. So, ganun. So for skewness, we have 0 for symmetric distribution. Greater than 0 is positively skewed and less than 0 is negatively skewed. Then for kurtosis, we look at the curve shape. Okay, we'd ideally want a bell-shaped curve that's symmetric about the mean, and the tail approaching the x-axis but not touching them on both sides. So, and the area below the curve should obviously be equal to 1. So there are terms depending on how the curve looks like. Mesokurtic refers to the typical curve. Leptokurtic for the very high sharp peak, and platykurtic, flat, no, for the apparently almost flattened looking curve or peak.